Welcome everyone, I'm Hangli from the University of Munich. Today I'm delighted to present our work at CVPR 2024, Self-Discovering Interpretable Diffusion Latent Directions for Responsible Text-to-Image Generation. This is a joint work with Cheng Zhishen, Philip Tor, Volker Trestman, Jindong Gu. Text-to-image generation has achieved remarkable progress, especially with the advance of diffusion models. However, such models pose risks of generating inappropriate content, such as biased or harmful image. For example, the images of doctors generated by Stable Diffusion are mainly males, revealing the social biases learned within those models. Also, the diffusion models may generate unsafe content, such as nudity and violence. Our goal is to mitigate such inappropriate content and achieve responsible generation. For that, we need to figure out the underlying reasons for diffusion model to generate such undesired content, which remains unclear. The question we ask is that, can we discover inappropriate concepts in the latent space of diffusion models and manipulate the internal generation process to ensure the generated images are fair and safe? For example, can we identify a latent vector that controls the generation of nudity content and deactivate that vector to remove such undesired concept from the output image? Fortunately, a few prior works has identified such semantic space within diffusion models. They found that the bottleneck layer of UNet, so-called H-space, exhibits properties suitable for semantic representation. That is, adding a vector to the H-space can manipulate the attribute of the generated image. However, previous methods developed to find such concept vectors in H-space are limited for responsible generation. The unsupervised approach requires human interpretation, and some target concept may not be found in the discovered directions. The supervised approach requires training external classifiers with human annotations. Hence, we propose an approach to finding any target concept in the latent space of diffusion models in a self-supervised way. Our method is shown in this figure, separated into two stages. To find the latent vector that represents the concept of female in the semantic space of a pre-trained diffusion model, the process is as follows. In the first stage, we generate a set of images from the diffusion model. The prompt contains the target concept, for example, in this case, a female face. Then, we optimize the vector in the H-space on the generated images with a few modifications to learn the desired attribute. Specifically, we follow the standard training procedure of a diffusion model, which is the model needs to predict the noise to get a cleaner image. But the prompt is modified to a person. We freeze the weights of diffusion model. Only the vector in the H-space can be optimized. To accurately predict the image, the model will use the latent vector to represent the missing information from the prompt, female. After optimization, the vector will represent the concept of female. Within this framework, we can learn a set of concept vectors related to responsible generation. Specifically, we manipulate the inference process by adding a desired vector into the bottleneck at each denoising step. Note that the inference is same as before, except that the single differences. For fair generation, we would randomly sample a concept vector that represents a social group and add it in the inference process. For safe generation, we will learn the direction that can surprise unsafe content and always adds that vector in the latent direction. We also introduce a third scenario for responsible text enhancing generation, where the user prompts are classified as responsible text. We aim to accurately represent the responsible phrases in the generated image. So in that case, we first extract such phrases from the prompt and then activate the corresponding concept during the inference process. As for the results, we tested the discovered vectors on those three scenarios. First, our method achieves state-of-art results on fair generation. And it's better than other debiasing method and much better than the original SD. Here are some examples produced by our method. The original stable diffusion mainly generates male doctors, but with our method, we can generate doctors of equal gender. For safe generation, we combine our method with existing safe generation method and achieve further improvement. For the third scenario, one example we create a data set with examples such as a keynote speaker, either male or female, at a technology conference. So on this data set, we tested our method and it outperforms the original stable diffusion. In summary, we made the following contributions. So first, we propose a self-discovery method for identifying interpretable directions in the diffusion latent space. Our approach can find a vector that represents any desired concept. Second, with the discovered vectors, we propose a straightforward approach to enhance responsible generation, including fair generation, safe generation, and responsible text enhancing generation. Thank you.